चांगले झाले तुम्ही डॉक्टर, चांगले झाले तुम्ही.
Very good evening, Dr. Manoj.
Good evening. Good evening.
And good evening to all the participants. So actually participants are still joining, so we can wait more 5 minutes.
Okay, no problem. Dharmen,
Yes, sir.
still participants are joining now.
Yeah. So can we start?
As you like.
Because actually we have around more than 100 participants, around 105. So, okay.
Okay, so no problem.
Yeah, we will start at 6:10.
Okay, so till that, I think I would like to
Yeah, you
interact
can.
with the participants.
Yes,
So,
that is.
voluntary, if anybody wants to introduce themselves, those and they can introduce. So, just have a quick
Even you can
introduction.
tell what is the expectation from this session particularly. Because this
Right.
this analysis, this particular session is devoted for the data analysis tools, which are generally used for your research purpose. So if you have any any special query or any expectation from today's session, so you can also share. So sir will take care of that.
Okay. No, I would like to prefer to interact with the participants. So if anybody is voluntary, just come on this platform. So just introduce themselves. What else they know about the analysis? Dr. Bindu.
So you can unmute yourself. There is no problem.
Dr. Dharmen sir, kindly
Yes.
allow to start. The participants are joining.
Okay.
You may start right now.
So I think first of all I have to introduce our today's resource person. So
Recording in progress.
very good evening to all the participants and welcome to this final day of 1 week online faculty development program on advanced research methodology that is currently organized by Amiruddaula Islamia Degree College, Lucknow and Science Institute. So it's really a great privilege for all of us that our today's resource person, Dr. Manoj Divakar, has joined as a resource person for this particular session on data analysis. So Dr. Manoj Kumar Divakar is presently working as assistant professor at the Center for Economic Studies and Planning, School of Social Sciences, Jawaharlal Nehru University, New Delhi. As you all know that it's a very renowned university. So Dr. Manoj has a very wide teaching and research experience in academia as well as industry also. So some major research area or area of specialization of Dr. Manoj is statistics, econometric and applied mathematics, research methodology, quantitative methods, health economics, clinical trials, biostatistics. He has expertise in various statistical software like SAS, PSS, R is data, SPSS demos. So he has some other research areas also. So thank you so much, sir, for being with us and for giving the opportunity to interact with our participants. And over to you, sir.
Thank you, Dr. Dharmen, giving me an opportunity to interact with the scholars and the faculties on this faculty development program. So I would be taking up the session on the data analysis. Let me. So I would be talking about the overview of statistical methods. So when and how you will be applying the statistical methods. So that's I'm trying to explain you in this session. So far you know about the what is the research, and every research must have uh, some activity which can be done by the researchers and um, the PI of the project. So here I would like to tell you more about the data analysis. Okay, so data analysis. Once we talk about the statistical methods, that will required once we will make a inference about the your objectives. Okay, so whatever the objective is with you, that needs to be needs to be explained. Okay, so let me do one more thing if it is work. Okay, so fair enough. So what do you understand by the research? So I would like to start with the very scratch. So I am just introducing the research. I think you all of you gone through this research. So research is nothing but it is a process, activity and problem and systematically. So it is a one of the procedure where we need to do activity about the your objective, data collections, methodology and the problem. So basically the every research or whatever you want to do in your PhD or in your project, that's a basically you want to find the answer of your problem. So this is something that is you would like to get the answer. So these research can be done systematically when we need to have some activity, and that can be done in that manner. So research is nothing but it is a process wherein activities are carried out systematically to find the solution of a problem. Okay, so your problem could be your objective of any research. Okay, other way you can say that you might be having the hypothesis when we talk about the medical sciences. So in medical research or in clinical trial, public health, we specifically talk about the hypothesis. That's you want to get the solution of those hypotheses. Okay, in general in social sciences you talk about the you might be having the objectives, and then you want to find out the answer of all those objective. Okay, so this can be done systematically, and these are there are the some activities. Okay, so that's activity you need to follow. For example, you must have the problem, and then you must have the review of literatures and so on, as you I think we gone through in the past days. Okay, so this is the about the research. Then what are the steps for the research? So research basically I would like to emphasize on these steps. So identifications of the problems. So if you know depthly about the identification of the problem, so what is your objectives? Okay, so what kind of the problems you will be taking up in your research work, that needs to be a very important steps of the research. And then after that you need to write them, write your problems, write your objectives in the form of the hypothesis. Okay, so in the form of the hypothesis means that later on you will be applying these statistical methods. Okay, so here you will be using the some statistical methods. So this you want to do the formulation of the hypothesis. Then after that, data collections, you need to go for the data collection. So you already done lectures on the data collection. So how you will go in the field, how you can go in the experiment if you are in the medical sciences. And then after that, you need to do a data analysis. Okay, so once the data is with you, so data in this form, so something nothing but it is a tabular form. Okay, so now next purpose is that you want to do a data analysis. So data analysis, how you can do a data analysis? That is the next step. Okay, so this is the next step when you will talk about the data analysis. So data analysis, here we will be specifically talking on the data analysis, how, what kind of the data is with you, then what kind of the analysis you can perform. Okay, so let's say you are having the categorical data, or you having the continuous data, then accordingly you need to identify, you need to look the respective statistical method that can be applied on the particular one. Okay, so after the, in the side of the research, we will morely talk about the identification and the formulation of the research problems. Okay, so formulations, because once you are doing the research in entire period of the 3 years, 4 years, 5 years about the your research problem. So research problem needs to be identified in the very proper way and systematically. Okay, so this is the very important aspect while we going for the data analysis, because we are getting the answer of these research problems. Okay, so later on, whatever we are testing or whatever the analysis we are doing, that is we are doing for the research problems. Okay, so whatever the research problem is with you, then you will go for the data collection and data analysis. Okay, so this for this the selection of the research area, so you must identify, you will be doing on the Ayushman Bharat, you will doing the study on the social aspect. So what is your research area? Review the literatures and their theories, what the literature is saying, what is the theory is saying in that particular area, in the research area. Then you will go for the research topic, research problems, and formulation of the final statement of your research problem. Okay, so this is the about the identifications and the formulation of your research problems. Now this is the entire research process. So this is nothing but this is the research process where you will talk about the research process. Okay, so you can define the research problems, then you will go for the concept and the theories, and then you will go for the previous research finding, then you can formulate your hypothesis, then you will design your study. Okay, so this is also important part, because you will be have a very limited time for your research. Okay, so it is oriented based on your problem. So whatever the problems, for that problems you need to design. Okay, so you need to look a better methodology for your research. Okay, so then you will talk about the data collections, that's you already done in the past lectures, and here today we will talk about these sections. Okay, and then after that you will do interpretations. Okay, so this I will not go much in the research process. And then after that, a lot of the once you will have the data, so data means you will getting the data in the form of the qualitative or quantitative. Okay, so some kind of the data is with you. Let's say this is the data, and then after that this kind of the data needs to be analyzed with the help of some statistical package. So a lot of the statistical package is available, the Stata, R, and then SAS, SPSS, AMOS, and this is for the qualitative data analysis. Okay, so the qualitative data analysis can be also done with the help of the Atlas TI. And other than this, there is many other software which is the commonly used. This MATLAB is there, and other software is there for the data analysis purposes. Okay, so you need to strengthen yourself on one particular software so that you can do analysis. Okay, so in the next line of this data analysis, we should know how to identify the data, because once you know the data, and according to the data, you need to decide about the statistical method. You need to decide about your data analysis. Okay, so you must be familiar with your data. Okay, so what is the data? So let's say your data is coming in this form. Okay, And before of that, you need to make some questionnaires. Okay, you need to preparing the CRF. You need to prepare a CRF or questionnaires for your research. Okay, so every questions needs to be understand. Every question needs to be understand in the sense of it is a nominal, it is a ordinal, it is an interval, or it is a ratio. Okay, at least you should know, because it is clear in the very beginning once you are designing the your questionnaires, then it is very good, and at that time only you need to decide about the your data analysis. Okay, so first I will talk about the nominal. So nominal is nothing but I'm saying you will be classifying, but there is no order and distance and the origin. Okay, so that is called the nominal data. And nominal data, for example, we talk about the genders, male and female. Do you have the public insurances? Do you have any insurances? So you will say that yes and no. So you will say that yes and no. So these kind of the classifications. Classification means these are the male, these are the female. These are the person who are having the insurances, who are not having the insurances. So this is a basically a classification. So such kind of the data is called as the nominal. Okay, so you need to tell about that. This is the first question which I'm asking in my questionnaire, that is a nominal. Second question is ordinal. Maybe third question is again nominal. So ordinal is what? So in the ordinal, this is a classification. So there is a classification and there is a order is there. Okay, but there is no distance and origin. So here there is a classification and order is there, but there is no distance and origin. Okay, so in this case, what is the classification? Again, here we are doing the classifications. Okay, but there is some order. There is a hierarchy is there. For example, we are talking for you got the first division, second division, third division, and fourth division in your exams. Okay, so or you are talking about the mild, moderate, and severe. So this is in a hierarchy, in a order. So such kind of the data is nothing but it is an ordinal. Interval and ratio. So this is the classifications order, but there is no distance. Okay, so here we will say that there is a data which is the we can classify, we can give an order and distance. Okay, so such kind of the data is called as the interval, and the ratio where we can say that the classifications order, distance, and natural origin is there. For example, if we talk about the age of the participants, okay, age of the your student, age of the your patients. So this is an example of, so you are measuring the age in 24 years, 28 years, 0.5 months. Okay, so this is the some example of the ratio, and according to whatever the data is with you, then you will decide about that. If it is my data is nominal, then I can go for the percentage, or otherwise I can go for the chi-square testing. So this is the thing that is you need to understand. So this is the so this is the basically let's just move. Okay, so this is the about your data. So what is your data? Accordingly, you need to decide about the your statistical method. So now, what is the analysis strategy? So once you have your data, okay, so let's say this is your data. This is the observation one. or this is the response 1, response 2, response 3, okay, response 4, okay, and so on. So this is the data is with you. Then after that, what is the your strategy about the data analysis? Okay, how you can do a strategy of your data analysis. Okay, so how you can decide about your data analysis. So it is the first way is that, so while you see the data, how it is look like. So by the visualizations, by the visualization, you can say that the data is pretty good as we expect. Okay, so you need to understand that it is good in sense of whatever you are expecting. So it is a good values. It is looking like a similar, which is we thought of the data would come in this form. Okay, so this is the your first strategy. So once you will be looking that this is my data, and then after that you will say that I will look this visualization with the help of the descriptive statistics. So first step of after the your visualizations, or after the looking it, then you need to talk about the descriptive statistics. Okay, so descriptive statistics is nothing but it is also a visualizations of your data. You just need to see that how your data is look like. Okay, so that is done with the help of the descriptive statistics. Okay, so descriptive statistics is the second step in the line of this. I can say that it is a second step, but it is a your first step to understand, to look your data how it is look like. Okay, so that is done with the help of the descriptive statistics. And then after that we can do a testing of your hypothesis, testing of your problems. That can be done with the help of the statistical inferences. Okay, so that is done with the help of the statistical inferences. And if it is your data is if you want to do the some prior information is there, some additional information about your data, then you can talk about the uh, um, testing is done in the sense of the prior informations. Okay, so this is the analysis strategy. Once you what do I plan to do with the data? So once your data is ready, then you need to plan for the strategy of your data analysis. So first step is that you need to go for the descriptive statistics. Okay, or it is basically a summary of your data, or it is a visualization of your data, how it is look like of your data. That's you doing with the help of the um, descriptive statistics. Okay, second step is the exploration. Okay, so explorations means, for example, I would like to see that how many students who got more than 60% marks. Okay, so according to the gender, according to the class wise, I need to do a cross tabulations. Okay, so it means that we have the two variables, and then we want to do a cross tabulation. That is the exploration of two or more than two variable. Okay, two or more than two variables. That's we do with the help of the cross tabulation. Then after that, we will talk about the discovering of the differences. Okay, so discovering the differences means we want to see that what are the differences is there. Okay, so for example, if you would be aware of the measures of uh, various parameters. Okay, so for example, let's say I will talk about the mean. So I will talk about the mean is there. So mean is the one of the parameter that is you are looking. So for example, you want to conduct a study where you want to see that what is the average salary of the your respondent. Okay, so that's you want to test. So average is nothing but it is your mean value that you want to check. you want to check the variance, you want to check the variance, you want to look the sum median value. Okay, so what parameters you want to look up, or you want to go for the proportion. Okay, so these are the parameters which you want to look through the discovering the differences. So you want to interested that the mean value of the two samples are the same, the variances of two populations are the same. Okay, so such kind of the answers can be done with the help of the hypothesis testing. So we will look here how this can be done. Next is the finding the relationship. So finding the relationship is nothing but you want to see that the measure of association. Okay, so measure of association. So between the two variables, one variable and another variable, you want to see that what is the association between these two variables. So this can be done with the help of the correlation and regression. Okay, so we will see that how the association can be done between the two or more than two variables. Okay, so this is the your strategy. So we will have the sub branches after the each of these sections. Okay, so if you talk about the discriminatory the inferential statistics, so that is under the hypothesis testing. Okay, so relationship, you want to see look the correlation, or you want to see the cause and effect. So that's you can do with the help of the regression. So here you can have a view of this slide, where we can have another slide for the research strategies. So here we have the quantitative. So quantitative is nothing but this is the ratio, and this is the interval data, and here your ordinal and nominal data. Okay, so if it is the qualitative and quantitative data, so main emphasis is on the numbers. So here we deal with the only numbers. So for example, as we discussed just now, age of the your respondent. Okay, so words. So I can write age in category. Okay, so your respondent will have the age between 0 to 25, 25 to 30, 30 to 40. So if it is, if we will do in categorical way, so that is the your qualitative data. So here we doing the theory of testing, deductive, and here we will doing the inductive. Structures form of the you must have the structures in the quantitative manners, then you will go for the generalizations, and this is the reliable data, and this is the data. Okay, so in unstructures, and the contextual understanding will be made in qualitative collections of the data, and this is the reap and the inside of your data you are going on. Okay, so the design are the case studies, so you will be looking at some case studies and the surveys. Here you will go for the narrative research and ethnographies. Then after that, we will go for the data collections. Okay, so data collections is you might be going for the highly structured interviews, secondary databases. A lot of the government data is giving to do analysis. You can go for the survey, cross-sectional and longitudinal. You can go for the experimental corrections. Okay, you can go for the census data. Okay, you can go for the NHFS data. You can go for the, so a lot of the data is available, and then you can go for either a primary or secondary data. Here unstructured and semi-structures interviews are there, and observations, written reports, social media, audience, audio visual. So these all are the your examples of the qualitative in sense of the data collections. Then data analysis. In the data analysis, you will talk about the descriptive statistics. Just now we talk about, and then after that, inferential statistics, where we will do the testing of hypothesis. Okay, and here we will do the text and image analysis, thematic analysis, content analysis. So these are the things that you can do for the qualitative data. Okay, so this is the majorly you will see the differences between these two categories. Okay, now I'm going to start with the outline with the some of the things on the comparing the mean value. Okay, so this is the basically comparison, or we want to look the differences between the mean value. Okay, so mean value with respect to one sample, okay, or this is with two sample and three sample. Okay, so that's we want to look here about the one sample, two sample, and three sample. So if it is one sample, mean value is there, or two sample mean value is there, and three sample, then how you will doing this one. So that is the one sample t-test will go for the one sample. So if it is there is only one sample is there, and then how you will doing the testing of the hypothesis for the comparison of the mean value. So that is the based on the one sample. T-test, that is the based on the two sample. Okay, then pair t-test, if you have the dependent sample or pair sample, then you will do a pair t-test. Okay, and after that one way analysis of variance, and we will look for the non-parametric methods. Okay, so again this is the something divisions where you need to understand that when and which kind of the test will be used. So this is the mostly in case of the nominal, or in case of the ordinal data is with you, then you are going to apply the discrete outcome variables. Okay, so the test name is the chi-square test, that is used for the two categorical variable. Okay, this is used for the two categorical variable. Fisher-Exact test, it is one of similar test for the chi-square test, but there is some different properties, or you can say that there are some different assumptions for this one, and then we will going to use the Fisher-Exact test, and then after that we talk about the logistic regression. So what is the logistic regression? So here we have the dependent variable. We have a dependent variable, and this dependent variable can be in the form of the nominal, means in the form of the yes and no. Okay, so present and absent, present and absent. Okay, so if it is such kind of the variable, dependent variable is with you, then you will going to use the logistic regressions. Okay, so if your data is coming in this form, then you will going to use this one. And survival analysis, that will be going for to understand that if survivability of the particular patients who got a cancer, who got a particular disease. Okay, so how much time it will survive. So such kind of the analysis can be done with the help of this survival analysis. So here it is also in this category. Another category is also, this is the for the continuous outcome variable. So what do you understand by the continuous outcome variable? Here we talk about the ratio or interval kind of the data. So if you have the ratio or interval kind of the data, then you can use this continuous outcome variable. This is the t-test. Okay, so it can be talk about the one sample or maybe a two sample. Prt test, when you have the pair sample. Okay. Analysis of variance. So it is the Anova. It is called as the Anova when we will look the three mean value, 1, 2, and 3 mean value. Okay. So we have the three sample, 1, 2, and 3 samples, and we want to see that there is a differences between the mean value of 1, 2, and 3. Okay. Analysis of covariances. Analysis of covariances is for pair sample. So if you have the pair sample, then and more than 2 samples, more than 3 samples, then we will be going to apply the analysis of covariances. Then next to this, linear regression. In this simple linear regressions and multiple and stepwise regression. So inside of the regression, it having the various types of the regression analysis, as you heard about the logistic regression, simple regression, multiple regressions. Okay, so there are the more than 20-25 types of the regression analysis, which separately require different time and the time to discuss about the regression types of the regression analysis. Okay, so and then after that we talk about the Wilcoxon rank sum test, Wilcoxon sign rank, and this is the correlations. Okay, so correlation means whatever we discuss about to look up the regression, to look the relationship between the two or two variables. Okay, so this is the about the some structures where you can see that the statistical method. So this is the based on the your data. So whatever the data, its type, you need to look the types of the your data. Is this nominal, ordinal, interval, ratio? Go back to your questionnaire. Okay, so what is your questionnaire? So what the types of the your first questions? What is the type of the your second question? Third. So similarly, you can bring out the your data and relate this data with the help of your questionnaires and linking with the your data analysis. Okay, so this is the related to each others. Okay, so all the things are related to each other. Now we will introduce about the concept of the parametric and non-parametric. Okay, so this is the concept of the parametric and non-parametric. Okay, so if it is, I'm saying my distribution is something like that, or my distributions is my drawing is not coming which. Okay, so my distributions is like this, and according to the distributions type, then we will talk about the parametric and non-parametric. Okay, so just have a just see the entire slide, and then I will talk about the what is the parametric and non-parametric. So here you can see the various tests is there. So in the statistics, it is one of the important part is not discussed much. That is the assumption of a particular statistical method. So whenever you going to apply any statistical method, then you need to have a assumption of the particular test. Okay, so whenever we going to apply the t-test, or whenever we going to apply a Prt test, or whenever we going to apply Anova, then you need to check that is that normally distributed or not, or it is the not normally distributed. Okay, so if it is your data is normally distributed, So whatever the information you are getting, that is the normally distributed, and its shape is coming like this. That is called as the parametric data. And if it is your data is in the skewed form, something is like that. Okay, so this is called as the non-parametric. So I'm making a division of this one, the test, the parametric and non-parametric methods. Okay, so let's see about the parametric and non-parametric. So first one is the, once we will have x is 2, so my sample is 2. So I'm having the samples 2, let's say x and y, and this is the normal. So it is normal means that it is the parametric. Okay, so if it is parametric, then your two samples are unrelated. It means that these are the independent. So sample 1 is independent, sample 2 is independent. Then you're going to apply this student t-test, and if they are related, then you're going to apply the pair t-test. Okay, so related means they are dependent. Okay, or they are before and after kind of the sample, before and after kind of sample. Then you're going to apply the pair t-test. Okay, so if it is your, this y is not normal, suppose you have the your objective, and then you wrote your questionnaires, and then after that you collected the data from the field or from the experiment, and then after that you realize that, or you looked up, your data is not normal, and you have two samples, x is 2 is nothing but there are the two samples, then it is the a case of the non-parametric. Okay, it is a case of the non-parametric, that is the Wilcoxon rank sum test and Wilcoxon signed rank test in place of the pair t-test. So if it is your data is related, then you can going for Wilcoxon signed rank test, and if it is your independent samples, then you can go for the rank sum test. Okay, so this is the, you can go for the non-parametric and parametric, and you need to check the normality of your data. If it is you having the more than two samples, so let's say this is the one sample, two sample and three sample. Okay, so this is the sample 1, this is sample 2, this is sample 3, or maybe more than that. Then y is normal. So if it is, we will look the normality of these samples, it is normal, then we will going to apply. If it is samples are unrelated, means these are the independent, then we going to use the one-way ANOVA. So here you're going to use the analysis of variance. Related, if your samples are related, then you will go for the repeated measures of ANOVA. That is, you will do here in case of the your data is normal. If it is your data is not normal, that means again you will be having the three samples and it is not normal, your, it means that your distributions is something like that. Okay, so it is not normal. That means that you can use the Kruskal-Wali in place of the analysis of variance, and in place of the repeated measures of ANOVA, that you will use the Friedman test. Okay, so this is the structures about the parametric and non-parametric, when to use the which kind of the test. So this is all about the your tests. So if you have any questions till now, then you can ask, otherwise I can go ahead. So you can just see this slide, and then after that you have any questions, then you can immediately ask, and then otherwise we can go ahead.
So the question. The participant, you can unmute yourself and you may ask any questions regarding to this presentation.
sir, very nice lecture. I like very nice lecture. I understand parametric, non-parametric, Anova, and other things. Lot of thanks, sir. Lot of thanks.
Okay. So do you have anything which you would like to ask?
Sir,
Yes.
in chi-square test, we are going to compute that result of categorical variable. That means we should not include numbers in that.
Yes. Yes.
Can you give one example for that, sir?
Okay. So let me talk you for. So you talk about the chi-square test. So in the chi-square test, what is happening that, for example, you will talk about you are having the one variable, that is the gender, and another variable is severity of COVID-19 disease. Okay, so we have the data in this form. So my data is the male, female, male, female, 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 and male. And the severity is like this. This is the mild, moderate, mild, severe, mild. Okay. So this is my kind of the data. And now I would like to draw a cross tabulation. Cross tabulation with respect to the category of the gender, that is the male and female, and category of the severity. So I will write here severity of the COVID-19 disease, that is the mild, moderate, and the severe. Okay, so this is nothing but how many numbers of the male who got mild COVID-19. Okay, so let's say this is the 4 cases are there. Let's say this is the 5 cases. This is the 10 cases. The male who got the moderate and severe is 5. In the case of this one, this is the 6, 14, and 20 cases. Okay, in female who got the severity, that is the 20. So I would like to see that there is a significance association between the gender and the severity of the COVID-19. So this we will do with the help of the cross tabulation, and then we will go for the chi-square calculations. So this is something on about your statistics. So in this case, similar to this, you can take many other categorical variable like a gender, education category, or whatever you have, whatever the research is with you, that you can take for chi-square testing. So that makes sense?
Sir, yes, sir, yes, sir. Thank you very much.
So any other questions till now? Should we go ahead?
I think there is no question from the participant side. So
Yes, sir. Go ahead, please. Go ahead, please.
Sir,
yes, Sabidas, yes.
when there is a one is in categorical and another is continuous in like this condition, if you give this example, what type of test there will be, sir?
For what?
among two variables, one in categorical and one in continuous. That time, how it will be?
Okay, okay. So let me. So let's say you having the one is categorical variable. One is categorical variable and other is the continuous variable. Correct. So this is your question. So in that sense, what you would like to do or what kind of the statistical method you can apply. So for example, I can take you are having the gender and other variable you can take number of year spent in education. Okay. So these are the two variables. So this is something this is the your continuous variable and this is the gender. So let's say this is the male, female, male, female, 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 male, male, female. Okay. And you spend, let's say 10 years, he spent 5 years, 8 years, 12 years. Okay, like this. So if it is, this is the kind of data with you. So I can assume that male is the my one sample and female is the your another sample. Okay, so I can frame that I would like to see that is there any differences between the year spent in educations in the male and female. Okay, so basically you can use here also the, if you want to check that the average years spent on education. Okay, so if you want to see this one, that you can do with the help of the t-test. Okay, so this is depend on you what is your hypothesis. Okay, so two variable is with you. Sometimes you will be having the nominal variable, nominal ordinal, or ordinal maybe a ratio data. So how you want to frame the your hypothesis. Okay, so in that case I can frame my hypothesis this one and I can use the t-test. Okay, so or if I will take another categorical variable, for example, let's say rural. What is your area? So I'm giving this is the rural, urban, or semi-urban, like this. Okay, so here I can see that my three samples are there. This is the rural, this is urban, and this is the semi-urban. And same, I'm having the data of number of years spent in education. Okay, so I can go for the analysis of variance to look the average spends in average number of years spent in rural or in urban or in semi-urban are the same or differ. So that can be done with the help of analysis of variance. So you can frame many examples with the help of the your example. So that is clear for you.
Yes, sir. Okay, okay, sir. Thank you, sir.
Any other more questions? Okay, so I think there is no further questions. So I can go ahead, I think. Huh? So now we will talk about the chi-square testing. So whenever we talk about the any test, as you are from the diverse disciplines, you all are from the maybe from medical or maybe from the social sciences. So you can understand the statistical methods or tests in a different way. So first you need to catch what is your data. If you familiar with what kind of the data you will get from the experiment or from the field, from the survey, or from the secondary sources, then after that you will directly talk about the your test. Okay, so here I'm talking for the chi-square test. This is the your chi-square test. So chi-square test, it is the most widely used non-parametric test, useful in the test involving the nominal data, but it can be used for the higher scales. Okay, so higher scales means you can go for the nominal or ordinal. The typical cases where the persons, the event or objective are grouped into the two or more nominal category or classes. Okay, so for example, you having the classifications A, B, C, D, you have the options of the favor, undecided, against. So any policy is given by the government, then it is the favor in favor of the public, or it is undecided, or it is against by the people. Okay, so this is the one example. Or if you have the yes and no kind of the data. Okay, so these are the some examples of the chi-square test, and then after that we will look how you can use the chi-square test. Okay, so so in the chi-square test, you want to see that you will be looking the here you want to test the significant association between the two categorical variable. Okay, so alternative, we will say that there is no significant association between the two categorical variables. Okay, so this is we do with here with the chi-square test. As I already told you that here we will have the important thing is that you need to do a cross tabulation. Okay, so this is the one categorical data, another categorical data, and do a cross tabulation. Okay, so this is the, and you want to see that this category is really associated or not with the other category. That's you will be looking with the chi-square testing. Okay, so this is the about the your chi-square testing. Now I will come on the parametric methods. Okay, or basically I just jump on the t-test. Okay, so the t-test, when to use the t-test, can anyone tell? Anyone just unmute and then tell about
It is a parametric test, sir. T-test is a parametric test. Am I right, sir?
It is
Parametric
it is a parametric test. But my question is that what you want to test with the help of the t-test?
Compare, sir.
Huh?
Compare two aspects.
Which two aspects?
Comparison between two groups. Two group means.
Group means. Okay.
Like as weight and height, sir. Height, weight and height. Yeah.
Weight and height. What?
Gender difference.
Huh?
Of the age group, age.
We'll compare the means.
With the
We'll compare the
population,
means.
population parameter, we would like to compare.
We'll compare the sample mean, two sample mean.
Two sample mean. Okay. So there are so many things is coming from the many things. So two population. Okay. Comparison. Okay. And someone said that you would like to, huh?
Difference.
Okay. So this is the, basically I would like to ask you that, let's say this is the, what is this? Mean. This is a parameter. In the layman, I can say that this is the, generally we talk about that, what is the average height? What is the mean height of the students? What is the mean height of the your patients? Okay, respondent. So here we will be talk about, whenever we talk about the t-test, so t-test means it will talk about the mean. It will talk about the average. It will talk about the average. Okay, then after that you will say that if it is your one sample is there, then it is looking that if this sample is equals to the some mean value or not, or if there are the two samples, sample 1 and this is the sample 2, so this is the mean value of this sample and mean value of this sample are the same or differ. So you saying that comparing the mean value, compare the mean value of one sample and compare the mean value of the second sample. Differences between the one sample mean value and differences between the second mean value. So you just phrases are some part of the your about this t-test. Okay, so basically whenever you need to recall the t-test is the mean value average you are looking. Okay, so you want to check the average of two samples, then we will talk about this thing. Okay, so now I will come to my one sample t-test. So what do you understand by the one sample? Can anyone tell? What is a one sample?
In one sample, only one time we can do the test on that samples.
Okay.
Only one time do the test. In
yes, second
Pre-test, post-test.
will not be pre and post will not be there in one time sample test.
Okay, so any other one?
In pair t-test, there is a subject.
No, I'm not asking you. Please give the other chance, or I'm not talking for the pair t-test. One sample, what is the meaning of one sample? Any other one?
When we are having one that sample, we are having one, and with the population parameters, we would like to compare whether according to our population parameter it is there or not. That time we are using one sample t-test.
Okay. So you all are partially correct, or maybe you were close to the definition of the one sample. So one sample means, suppose I would like to do some experiment in JNU. Okay, so JNU is a very big university. So I would like to see that the IQ of JNU. So I would like to see that IQ of JNU is same as 105 or not. Okay. So JNU is my one sample. So entire JNU is there, and I picked up some sample from the entire JNU. So whenever we have only one population, and from that population we bring out only one sample. Okay, so it means that this is, we are talking for the one sample. Okay, in layman I will say that something is there. This is your population, and you take out only this one. So this is your sample one. Okay, let's say this is the population. The same here I mentioned, this is the population, and I took two sample. Okay, so this is the two sample. Basically here we talk about the two samples. Okay, so we need to understand the sample. Two samples can be taken from the JNU as well as DU. So DU is the DU university students is the one sample, and JNU is the another sample. Okay, and whenever we talk about the only one university or one sample, that means it is the one sample. Okay, so let's say now I will come back to the one sample t-test. So whenever we talk about the one sample t-test, means there is only one sample. For example, we will take about the IQ of JNU, that is equals to 105. So I'm just hypothetically assuming that the JNU IQ level is close to 105. It is equal to the 105. So in case of the one sample t-test, one independent sample is there, and comparison between the one group of sample. Okay, so this is the comparison between the one group of sample. So you will write, compare the mean response from the one treatment group of the some existing value or hypothetical value. So this is your what? This is your hypothetical value. Okay, so in this case you will write H0 is average value of sample 1 is not sample 1, it is a sample only. It equals to 105, and alternative it is not equals to 105. And then after that you will see that this is the x bar minus mu over sigma by root n. Okay, so this is give you the t calculated value. This will give you a t calculated value. So this is the about your one sample t test. It is clear for all of you. When you have the one sample and you are checking with the some hypothetical value. Okay, so this is about your one sample t test. Now we can go ahead for the two sample t-test. So while we talk about the one sample, okay, so you can take the t calculated, you can take t tabulated, or you can use the p value. So p value is less than 0.05, then reject h naught. When p value is greater than 0.05, it means accept h naught, and technically we will write fail to reject h naught. Okay, so this we will do a decision. This is what you are doing, the decision about the your hypothesis. Okay, so your hypothesis was mu is nothing but 105. Okay, alternative was mu not equals to 105. That's you are looking in the case of the one sample t-test. So either you will do one sample t-test, two sample t-test, you will do the interpretations with the p-value. So p-value is less than 0.05, then reject h naught. If it is greater than, then accept h naught. So this you need to do for all. Okay, so that's you need to remember. So you need to learn this, or you can remember this while you make a decision about the your hypothesis. Okay, now I can go ahead for the two sample t-test, that is your two independent sample. Okay, so two independent sample comparison between the different group of subject. So compare the mean response from the treatment 1 and 2. Let's say I can take another example, IQ of JNU. This would be your one sample. Another sample is IQ of Delhi University. Okay, so I'm just checking the mean value of IQ of JNU is same as the with respect to the DU. Okay, so this can be used in the in the two samples. So two sample may be your male female, maybe from the different locations. You doing the study in the two districts, and then you can also say that the some parameter whatever you are taking up, that can be looked up. Okay, so what is the pair t-test? It is the one sample. Here I'm taking only one sample, but it is related with two different time. Two different time. It would be taken at a two different time. For example, you all participants are here. So before of this FDP, we are assessing your knowledge on the research methodology. And after of this training program, after of this faculty development program, we are again assessing your knowledge on the research methodology. So what is happening? The participants are the same, but the time interval is different. Before of the training and after of the training, what is your knowledge on the research methodology that you are doing with the help of the pair t-test? So this is called the before and after. Okay, that is called the Prt test. This is clear for you. And there are the more example. Blood pressure change from the baseline means those who are from the medical sciences, they can assume that, let's say the people got the fever during the COVID-19. So everyone is taking up the paracetamol. So what was your temperature before of the paracetamol medicine and after of the medicine? Okay, so the same patient is there, but you are looking the how much the temperature was at the time of the before of the medication and after of the medications. Okay, so such kind of the things can be done with the Prt test. Is that clear? Now we will look one by one. Okay, so this is the student t-test. So student t-test means two samples are there. So this is your one sample, this is the another sample. Okay, so to test or compare. So here you can write compare differences, compare the mean from two different group. Okay, so there are the two different group or two different sample of the subject is computed. Okay, so T is nothing but the mean of sample 1, mean of this one, and this is the mean of this one, divided by the variability of these two samples. That is the difference in the mean, and this is the variability, and this will give you the T statistics. Okay, so this is the statistic. Okay, so this is still C. So this is the T statistic, and this will give you the difference is significantly different from 0 when compared to the variability. So this is about the student t-test. Now I need to tell you about the assumptions. Assumption is the important part of the all statistical methods. So what are the assumption is required while you doing the t-testing? Okay, so you can see that samples are independent. This is your one sample and this is the another sample. So these needs to be independent. It means that the value of one will not change or will not depend on the others. That is, your samples are independent. Okay, for example, IQ of JNU is differ and DO is differ because both are the different students. Bell-shaped distributions like a normal means the distributions would be something like this. It means that sample ISCA distributions is similar to the normal. It is also a normal. Okay, the bell-shaped curve is centered around 0 and the tails are slightly thicker than the standard normal bell curve. Okay, so t-test is applied when our sample size exceeds 30 and distribution will be the same as the standard normal variate. Okay, so this is applied for the smaller sample. So a smaller sample something which is close to the lesser than 30. So how you will do decisions in case of the student t-test where we will be looking the differences larger than the expected by chance. Okay, so this is the do not reject H naught. This is the basically a T distributions, and this is the alpha by 2. This is alpha by 2, that is the critical regions. Okay, this is the observed statistics, and here the p value reject H naught. If it is the value coming here. That is the p-value rejecting H0. Okay. So in the student t-test, is the difference larger than expected by chance? So when the observed t-statistics is so large in the magnitude that it falls outside the region marked by the two critical point, we conclude that the observed differences is larger than the expected by chance. Okay. And here the alpha is level of significance is 5%, chance that we made the wrong conclusion. So this is the, we will see that we are sure 95% about the my hypothesis. Maybe 5% there is a chance we made a wrong conclusion about the my idea. Okay. So these are the some more example where you can understand the student mark, and this is the students marks too. Okay. So basically this is the class 1 and this is the class 1 and 2. Okay. So these marks are there. And then you want to see that the average marks of this one is same as the 2 or not. Okay. So this we will do with the help of the t-test. So this can be done with, you can find the mean, variance, observations. Okay. And this will give you the t-value. And here you will find the p-value. Okay. So this is your p-value. If I will log this p-value, so p-value is nothing but 0.04. Okay. Which is less than or less than 0.05 or greater than. Accordingly, you can make the decision about your hypothesis. Okay. So this you can do with the help of the Excel, or you can do with the help of SPSS or SAS. So there are the many options for you, how you would like to do your analysis, which software you would like to do, that's depend on you. If I will consider you want to do this in the SPSS, so it is very easy. You need to go into the analyze, then go for the compare mean and independent sample t-test. Then we talk about the grouping or categorical two variable. And here you will put the two test variable. And if you want to do a pair t-test, then there is a two option is there. Then you will talk about the which pair is there. So you need to mention about the pair 1. And this is the pair 2. Okay. So inside of the factors, you need to tell about the factor 1 and basically pair 1 and pair. This is for the one-way analysis of variance. So this I will do later on. Okay. So this is about the your one sample, two sample, or pair t-test. So is that clear?
Yes, sir.
Okay.
Sir, what was difference between one tail and two tail t-test? Like you took the example of a two tail t-test that where the p value was 0.04. But just
Right.
above that in the previous slides, there was one also p value t-test, one tail t-test. So why you did not take one tail t-test? Why you took only two tail t-test? How to interpret it? That which one we need to take?
So let me recall the previous example, that is the one sample t-test. So H0 is something mu is less than 105. Okay. Let's say this is the my hypothesis. So if it is, I'm just saying that it is the greater than or it is the lesser than, then we will use the one sample t-test. Okay.
Okay.
Similarly, if we talk about the mu1 and mu2, here if it is used sure that your drug is more effective than the in the existing drug in the market, then you will talk about the this is the one tail test.
Okay.
One tail test. Okay. Let me tell you one more thing, that is the paired t-test. So here we talk about the T is defined as okay. So here the D is nothing but xi's minus of pi i's. Okay, and the variances is of this one. So let's say this is the pre value and this is the post value. Post value of medications. So in this case, here this is your xi and this is the yi. Then you will need to take out the di is nothing but xi is minus phi I. And this is the t calculated form. Again, you need to do the same thing, the hypothesis testing for the paired t-test. Okay, so this is about the paired t-test. Now we will talk about the analysis of variance. So in the analysis of variance, when we want to make a statistical inference about a set of mean, okay, so here we talk about the set of mean from more than 2 treatment groups. More than 2 treatments group means you would be having 1, 2, and 3 groups. Okay, so maybe a 1, 2, or 3 and more than that. So this is the group 1, this is group 2, and this is the group 3. Okay, so in these situations, we will talk about the analysis of variance. Okay, although more than 2 treatments means are compared, what we are doing, we are comparing the mu1, mu2, and mu3. Okay, this procedure is called analysis of variance. So comparing the average of 1 sample, average of 2 sample, average of 3 samples, that is your analysis of variance. Now we talk about the total variability in the data is partitioned to the test the differences among the mean. Okay, so let's say one-way analysis of variance. So this is the one-way analysis of variance. It is based on the F-test. Here we will use the F-test. Okay, so here compare the sample variability between the group with the sample variability within the group. Okay, so here the F statistics, with that also called as the test statistics, is nothing but what we are doing in the t-test, that is the differences in the mean value. Here also we do a differences in the mean value and divided by the variability of the differences. Okay, so let's see with this example. Okay, so we are having the 3 samples. The one set of people who are getting the 0 dose of the medication, 10 mg and 30 mg. Okay, so this is the 30 mg, 10 mg, 0 mg. People are getting these kind of the drugs. Okay, so basically we would like to see that how these value are far from the your mean value. Okay, so this is basically this is your mean value, and then you will see that how these other values are far away from the mean value. That is you would like to see in the analysis of variance. Okay, and you want to reduce these differences value. Okay, so we will write the model of analysis of variance. That is the Yij mu I plus epsilon Ij. Okay, so this is nothing but it is the response of jth subject from ith treatment group. This is the mean response of ith treatment group. And this is the random error associated with the jth subject from the ith treatment group. So whenever we talk about the analysis of variance, it means that it following all the assumption as we discussed earlier also in the t-test, and adding to this assumptions, the error terms are the independent, are normally distributed with mean value and equal variance sigma square for each group. Okay, so this is we assuming about the analysis of variance. Let's we write the hypothesis. Okay, so null hypothesis is what? It is a null hypothesis that all mu i's are equal. It means that we can also write as mu1 is equals to mu2 is mu3. For example, average IQ of JNU is equals to average IQ of DU and average IQ of Jamia Millia Islamia. Okay, are these same or not? Here in alternative, we will write at least one is differ. Okay, so maybe a one differ from the other. Maybe mu1 is differ with mu2, or maybe mu1 differs from mu3, or mu2 differ from the mu3. Any one of them is happening. Okay, so using that's a T statistics, or sorry, F statistics, the F distribution, we can obtain a p-value. As I told you that you do a F calculated and you will get the p-value. The probability of observing a test statistics as extreme as observe the value by chance. So here we will make the decision. So basically you can understand from this bar chart that all means are equal. Okay, so this is 0, 10 and 30 mg, and these all means are not equal. Okay, so how you make the decision based on the p-value? So p-value is less than 0.05, that means rejecting H0. If p-value is greater than 0 and 0.05, fail to reject H0. So this is we doing in case of the analysis of variance, and this decision rule was the same for earlier t-test. Okay, so this is about the analysis of variance. So analysis of variance, once we got that p-value is less than 0.05, okay, it means reject H0. That is means mu1 is differ with mu2 or maybe mu3. At least one is differ. So this is we got as F test is significant. We are interested to know which treatment means are differ. Okay, so which treatment means are differ That we will do with the multiple comparison procedure that used to answer such questions. For example, either a mu1 is with mu2, mu2 with mu3, or mu1 with mu3. So which one is differ? That's we need to do with the help of the multiple comparison. So this is the another part, or this is the another extension to the analysis of variance. Okay. So here we will do a comparison with the made of the contrast and estimate statement. This is the one example. Okay. So this is the ICT flavor are taken. So flavor 1, flavor 2 ICT, or flavor of 3. So these are the 3 samples. This is the 1, 2, and this is the 3 sample. Okay, so there is some disturbances coming. Please unmute yourself if anybody is. So this is the first sample, second and third, and then you will run the F test, and then you will get this value, F value, and this is your P value. Okay, so this is the Anova output. Okay, so we need to look, this is the F calculated, means 2.52, and P value is 0.09. Okay, so based on this value, you can make a decisions about the sample 1, 2, and 3 are the same or they are different. Okay, so in a ANOVA, this is again I'm talking about the ANOVA. So in ANOVA, you need to check the assumptions. Okay, in as well as you need to check the assumption in t-test. So this figure is 1 is there and figure 2 is there. So do you think that this exists with the normal distributions as well as the equality variance? Are these following by 2 diagram? Can you suggest what is happening in that? This is not a normal. You can see that this skew data is there. So this is not normal distributions. But these are the normal, but this is the normal distribution but unequal variances. Okay, so the assumption of analysis of variance is not met by these two pictures. So this is the basically a sample 1 and this is the sample 2. This is sample 2. So here you can see that the variability is also same, and this is a normal distribution. This is like a normal distribution. So this is the major important assumption of the analysis of variance, that equality of the variance is the most important assumption of the analysis of variance. If the variances are not equal, then the statistics are not valid. Means whatever you inferring, that can be a wrong. Okay, so you always need to check the assumptions while you make your decision. Okay. So if you plot the residual so that some concern them use a transformation of the data. If it is your residual is not coming up, then you can transformation. So there are some treatment needs to be given. Okay, so treatment means you can transform your data in a different forms. And if it is coming in a normality or in a variability or in other forms, then you can use the analysis of variance. If it is not coming, then you need to decide that the transformation does not take care of the problem. Still, it is not coming a normal distribution. Then the residual of the model based on the transformed data does not seem acceptable. So then you can go for the non-parametric. So non-parametric for Anova is nothing but it is a Kruskal-Wali. Okay. So now we will look what is the differences between the parametric and non-parametric. So I'm going for the back to the what you will do in the t-test or in Anova. You are looking the mean value. Okay. What you will do in a non-parametric method, you will take the median value or you will take the rank. Okay. So here you will taking the mean as your parameters, but here you will take the median and rank. Let's see what is happening here. So if one or more of the parametric assumptions are normality and equality is violated, then non-parametric is for the equality of the treatment means is more appropriate. Simulation tests suggest that parametric Anova is fairly robust against the departure from the normality, but not from the inequality of the variances. In general, a parametric Anova is preferred test in the most of the cases of the data is continuous and the sample size is very small. It is the rank based. I told you that sometimes you will take the rank or some median value for the non-parametric test. So applications when the data is normally not normally distributed, then when the group variances are unequal, then you will go for the non-parametric test. Okay. So non-parametric method compare the center idea, that is the median of two samples. So median of sample in this manner, this is your null hypothesis, this would be your alternative hypothesis, and replace your data with their ranks. Okay, so whatever the data is with you, that needs to be replaced with the rank. So you need to give 1, 2, 3, 4, 5 ranks. Okay. Let's talk about the Kruskal-Wali non-parametric methods in so it is analogous to one-way ANOVA. Rank all the data. Rank 1 is the smallest value without regard to which the treatment group they are in. Calculate the sum of the ranks. This is the way of calculating the Kruskal-Wali. Okay, and this is the test statistics. Earlier we used the T or F. Here we will use this test statistics. That is this one, and test statistics is compared based on the chi-square distributions. Okay. So in case of the test statistics is based on the chi-square distributions, does not use any assumption about the distribution of the data. So what is the difference between the non-parametric and parametric? Inside of the parametric, the assumptions are very important, but in non-parametric, assumptions are not very important. So that's why we are using the non-parametric methods. So does not use all informations of the data. So basically what you are doing here, you are giving the rank 1, 2, 3, 4, 5. You are not using the original data. You are not using your raw data, but here you giving some ranks, and then after that you will be. So this is the less powerful than compared with the analysis of variance. Okay, so this is the parametric test and this is the non-parametric test, which we already discussed before of this. So this is about the parametric and non-parametric methods. Okay, so let me tell you one more thing. This is the family of regressions. Okay, so once we have the data x1 and y is your continuous data. For example, number of hour you study or marks obtained in exams. Okay, so in this case, you will apply the correlation to look, is there any relationship between the x and y. Then after that, regression family will come up. Here, if your data is nominal dependent variable, then you will use the dependent variable has 2 labels, dependent variable has 3 labels. That is called the logistic regression, multiple logistic regression. If we have your dependent variable, okay, so here we will see that dependent variable is equals to independent variable in case of the regression. So if your dependent variable is 0 and 1 or mild, moderate, severe, then you will use the ordinal logistic regression. Okay, so if it is your dependent variable is interval, for example, you having the height of the student, okay, then you will go for the linear regression. And if you have the multiple independent variable, then you will go for the multiple linear regressions. And there is a further classifications, further families of the regressions, which maybe we will discuss maybe in other class. So this is an overview of entire statistical, not entire, but some of them, which is the commonly used during your analysis. So this is all about my presentations. Now it is open for you all. You can ask the questions if you have with related to my presentations, or if you have any query which exists in your mind that you can discuss here only. So is there any questions?
Interested participants, you may ask questions regarding to these presentations. There are only 6 minutes remaining to complete this session. So I request you all participants, if you have any doubts regarding to this presentation.
My simple question is that, sir, my simple question is that what is different between F test and T test? What is different between F test and T tester? Okay, sir.
So F test is something which we will use for comparison of the mean value for the more than 2 samples. Okay.
Yeah.
And
yeah.
if we talk about the T test, that means we will be using the 2 sample.
Mean of 2 sample. Mean of 2 sample.
Yes.
T for mean of 2 sample. Okay.
Yes.
Okay.
Can you explain once again the one tail and two tail T test?
So one tail and two tail test. Two tail is when we talk about my null hypothesis saying that equality of the 2 parameters. For example, mu1 and mu2 are equal. And alternatively, we say that it is not equal. So that is the two tail test. Means we will be using both the tails of your distributions. Once we will talk about let's say my null hypothesis saying that something is greater than, the mean value is greater than 10,000. Let's say the average salary of Indian population is 10,000. So this is the greater than or it is lesser than that. In that sense, we will be using the one sample T test. Is that make sense?
Yes, sir. Yes, sir. Thank you.
Any other question? This is the open session for all of you. You may ask any question.
Sir, I can summarize in this way. For association, we need to do that categorical variables, and the test is chi-square test. For strength of association, we need to do this parametric test. That one is t-test and Anova. For correlation, we need to do correlation analysis and regression. Logistic and linear regression. Logistic for non-parametric test, categorical one, and linear regression for continuous variables. Is it okay, sir?
No, it's not exactly okay with you, but you cover the entire. But what is your problem that you need to ask? That is fine, you are saying, but
means I'm comparing this with epidemiological studies, sir. That one, descriptive study, analytical, and that experimental one. For that, just correlating which one is correlate with that one. For descriptive, chi-square is the one. We need to get that result of association. Then for analytical, we need to get that strength of association by with using the t-test, and that correlation.
It is fine. It is fine.
Yes.
We discuss about the what kind of the test you can use, as it is depend on the based on your assumption. What is your hypothesis? Based on your hypothesis, you can decide. Okay. So whatever is your problem, you can decide based on your hypothesis.
Okay, sir. Thank you, sir. Thank you very much, sir. Very informative and very explanatory, sir. Most of the cleared actually.
Okay, okay. Any other questions from your research or from your thesis or anywhere? Any question? Any?
Yes, sir. When we want to look for correlation between x and y variable, if both variables are continuous, then we will use regression analysis. And if suppose one variable is continuous and other is nominal or categorical, when we want to see correlation between categorical and continuous variable, then will it be some different test of regression?
See, once you will be having, this is your dependent variable and this is your independent variable. Okay.
Yes, sir.
So this is basically y is a plus bx plus some error terms. Okay. So if this y is, for example, yes, no. Okay.
Yes, sir.
Then we will talk about, we will use the logistic. Okay. If it is your continuous variable, for example, blood pressure. For example, 120, 90, 50, 80. Okay.
Yes, sir.
So this is your y. Then we will use the simple linear regression. Okay. Here my independent variable is only one. When we have the independent variable is two, maybe for example age and the workload, two variables. Okay. Then we will use the multiple regression.
Okay, sir.
So based on this, if you have the categorical or ordinal, you will use the ordinal logistic. And if you have this one, then you will use the linear regression, and otherwise you will go for the multiple regression. Okay.
Okay,
If
sir.
you have, suppose here multiple variable, dependent variable, multiple variable, then it is used as the multivariate analysis. Multivariate analysis.
Okay, sir.
Okay.
Thank you, sir.
I have one query.
Yes, yes.
For questionnaire-based epidemiological study of a disease, particular disease, which statistical tool will be best for analysis?
It is difficult to say about that if you have any epidemiological study, and so it is based on the objective. In the very beginning or in most of the slide, I just talk about you need to have a clear idea about what is your objective. Okay, so if you have the objective, then you can easily decide that what kind of the test you will use. In epidemiology, maybe we can use the t-test, maybe we use a regression, maybe we can use proportion, we can use the ROC curve. So I cannot say anything. But if you tell a specific problem, a specific objective, hypothesis, then you can easily decide. Is that clear for you?
Sir?
Yes.
Sir, actually, in systematic review, we are using forest test. So in that, how to interpret and understanding, if you are explaining, it will be good, sir.
Forest test, I think, I'm not sure because I haven't done that. Hello. Hello.
Yes, audible, sir.
Yeah. So I think you talking for the forest plot or something forest test.
Forest plot, sir. How to read that? How to interpret that?
Basically, it is the forest plot is in the systematic review. Just for example, I'm taking the one study on the shoulder pain. Okay, it is the ortho study, and we found that why the shoulder pain is occurring in a different articles. Okay, so you have to take some parameters and look that what is the average difference between these values. Okay, so different in one article, two article, three article. So that can be drawn with the help of the forest plot, so that you can judge based on the particular parameter. So if you have the 4 parameters, then you can draw a 4 different forest plot and compare these values with respect to the each your review article. Is that something is understandable for you?
Thank you, Sebi. And sir, please share your email in chat box, sir. And if you have any doubt, you may ask to sir. So, and all the participants, if any query, you can email our official email, and we will forward to sir, and sir will reply, and I also will forward to you. So, thank you, sir, and thank you to all participants for joining this 1 week faculty development program. And thank you, Manoj sir, and coming for this platform and delivering this wonderful presentations. I think it is very useful for the all all participants. And now our FDP chair, Professor R.K. Shukla sir, has joined. So I would like to invite to Professor R.K. Shukla sir. Please come.
Good evening to everyone connected here. I thanks all the participants and esteemed speakers to this faculty development program organized by Islamia College and Science Tech Institute. Faculty development program is an opportunity to get to touch with recent, latest and cutting edge development throughout the globe. I believe that this FDP is beneficial to all the participants. I would like to thank Mr. Jafar Jelani ji, Manager, Islamia Degree College, Abdul Qayyum ji, Principal, Islamia Degree College, Dr. Dilshad Ahmed Ansari, Dr. K.C. Dubey, Dr. Muhammad Sajid, Dr. D.K. Yadav, they are FDP coordinator. I also thank Ms. Sweta Singh, Chairman, MKSCS Educational Society, and Dr. Sushil Singh, Director, Science Tech Institute. Once again, I thank everyone to participate this FDP program. I believe that this program is beneficial to all participants. If they have any doubt, they can write us and we forwarded their problems or their query to the resource person, and I sure they answer you and we will send you back those question answer. Once again, I thanks everyone. Jai Hind, Jai Bharat.
Thank you, sir. Without you, it was not possible to this wonderful FDP, and your blessing always with me and us. So now I would like to Professor Dilshad Ahmed Ansari. He is convener of this FDP. So Dr. Dilshad sir.
Good evening, everybody. 1 week online faculty development program on advanced research methodology जो 21 से लेकर 27 तारीख तक सफलतापूर्वक जो है चलाया गया, और इसमें जो है 7 विशेषज्ञों ने जो है भाग लिया, और इसमें जो है इसको व्यवस्थित ढंग से चलाने के लिए जो नॉलेज की जो है किस तरीके से जांच की जाए, रिसर्च के लिए इसमें क्या क्या इसमें बेनिफिट हैं, डेटा कलेक्शन के लिए, विजुअलाइजेशन के लिए, और इसके जो रिजल्ट किस तरीके से प्रेजेंट करना है, और शोध किस तरीके से लिखा जाए, रिसर्च किस तरीके से लिखा जाए, रिपोर्ट कैसे तैयार की जाए, और जो लिटरेचर की में जो चोरी होती है उसके खिलाफ रोकथाम के लिए जिसको प्लेगरिज्म कहते हैं, इन सब चीज़ों के बारे में बताया गया। हमारा ये प्रोग्राम 2 मोडों पर चलाया गया है। पहला तो आप जूम के माध्यम से जो रजिस्टर्ड मोड है, दूसरा अनरजिस्टर्ड मोड इस बार यूट्यूब पे भी चल रहा है। पिछली बार यूट्यूब पे नहीं चला था, 1 साल आज हमारा ये पूरा हो रहा है। पिछले साल भी हमारी ये जो FDP चलाई गई थी, जिसमें जो पहले विशेषज्ञ थे मिस्टर प्रोफेसर NB सिंह साहब, जिनका जो टॉपिक था डिफरेंट एस्पेक्ट रिसर्च, जो है बहुत ही सरल भाषा में इन्होंने जो है बोला, और हमारे यहाँ जो UG के जो छात्र थे जो जुड़े थे, उन्होंने बड़ी सराहना की, इतनी सौम्य भाषा का इस्तेमाल करते हुए उन्होंने इसको प्रोग्राम के पेश किया। और दूसरी हमारी थी अनामिका गुलाटी, जो JNU की थी, जो पहली बार इस प्लेटफॉर्म में आई थी हमारे इस प्रोग्राम में, सिस्टमेटिक रिव्यू एंड मेटा एनालिसिस के ऊपर दिया था, जिनको आप लोगों ने पसंद किया। बाहर में जो हमारे यूट्यूब में हमारे फॉरेन के लोगों ने, कई लोगों ने इनके प्रोग्राम को भी लाइक किया है, इनकी स्पीच को भी लाइक किया है। तीसरी हमारी प्रोफेसर निशामणि पांडे जी, जो KG मेडिकल कॉलेज या किंग जॉर्ज मेडिकल कॉलेज के नाम से जानते हैं लखनऊ में, ये एथिक्स इन रिसर्च पे किया, इनको भी बहुत सराहा गया, इनको भी बहुत से लोगों ने, बाहर के लोगों ने भी इनको पसंद किया। तीसरे हमारे जो है एक्सपर्ट थे डॉक्टर SK यादव BBAU के, तो इन्होंने डेटा कलेक्शन विजुअलाइजेशन के ऊपर बहुत अच्छा बताया, लोगों ने भी इसको भी बहुत सराहा। चौथे हमारे थे विनीत कुमार, ये भी BBAU के थे, ये भी रिसर्च एथिक्स और पेटेंट, कॉपीराइट और प्लेगरिज्म का, ये हमारे कॉमर्स का भी हिस्सा है, इसके बारे में बहुत खूबी से बताया। और इसके बाद हमारे जो है 5वें जो एक्सपर्ट थे डॉक्टर यूसुफ अख्तर BBAU के, रिसर्च राइटिंग, रिपोर्ट राइटिंग, इन्होंने जो है जो मैगजीन के ऊपर जो है फैक्टर नंबर होता है और किस तरीके से पीर रिव्यूड जर्नल होते हैं, जो आमतौर से लोग नहीं समझ पाते हैं, जो नए लोग इसमें आ रहे हैं, बहुत अच्छी तरीके से बताया। इनमें तो हमारे के फ्रांस के भी एक आदमी ने इनको जो है पसंद किया, इनके बारे में भी लिखा है। इसके बाद आज हमारे डॉक्टर मनोज दिवाकर जी ने, जो JNU के हैं, इन्होंने बहुत अच्छा बताया। बहुत से बच्चों के जितने पार्टिसिपेंट ने इनकी क्वेरी की उनको बहुत अच्छे अंदाज से बताया, और एक नई चीज हम लोगों को भी समझ में आई कि हाँ किस तरीके से रिसर्च में क्या क्या चीज़ों का इस्तेमाल होता है, किस तरीके से किया जा सकता है, और जो हमारे लोग कर रहे हैं इसमें इन्वॉल्व हैं उनको बहुत ही समझ में आया होगा, उसको पसंद आया होगा और उसको जरूर बेनिफिट मिलेगा। इस प्रोग्राम में हमारे जिन्होंने परमिशन दी उसके हमारे कॉलेज के जो मैनेजर हैं मिस्टर जफर याब जिलानी साहब हैं, इंटरनेशनल पर्सनालिटी हैं, इस वक्त वो बीमार चल रहे हैं, पूर्व सरकार में एडिशनल एडवोकेट जनरल भी रह चुके हैं, और इस वक्त जो है वो हाई कोर्ट के जो है सीनियर एडवोकेट हैं, और इनके ऊपर फिल्म भी बन चुकी है जॉली LLB 2, जो लोग देखना चाहें तो देख सकते हैं, इनके कैरेक्टर देख सकते हैं, हमारे कॉलेज को भी देख सकते हैं, 100 साल पुराना कॉलेज भी हो चुका है। तो उनकी जगह पर हमारे को चेयरपर्सन जो है डॉक्टर अजहर नबी साहब देख रहे हैं, जो कि हमारे असिस्टेंट मैनेजर हैं। को पैटर्न हमारे जो है अब्दुल कयूम साहब, डॉक्टर मोहम्मद साजिद साहब, ये दो लोगों ने इस प्रोग्राम में सहयोग दिया है। एक छुपी हुई पर्सनालिटी हमारे बीच में डॉक्टर श्वेता सिंह, जो पर्दे के पीछे से रह के उन्होंने पूरी तरीके से प्रोग्राम को सही तरीके से चलाया है। और इसमें जो सबसे ज्यादा मेहनत वाला, बहुत अच्छे तरीके से प्रेजेंट करने का काम है डॉक्टर धर्मेंद्र जी, जो है जिनको सब लोग बहुत पसंद करते हैं, बहुत अच्छे तरीके से प्रेजेंट करते हैं, डिपार्टमेंट ऑफ स्टैटिस्टिक्स न्यू दिल्ली से हैं। SK सिंह साहब जो है डेली आपको दिखलाई देते हैं, सारे प्रोग्राम को कोऑर्डिनेट करते हैं। इसके अलावा डिपार्टमेंट ऑफ सोशियोलॉजी की सुशीला जी हैं, MG कॉलेज की नोएडा से थी, और हमको आप जान ही रहे हैं मैं डॉक्टर दिलशाद अहमद सारी इस प्रोग्राम में ऑलरेडी शामिल हूँ और कोऑर्डिनेटर की हैसियत से। इस प्रोग्राम में जो जिन्होंने और सहयोग दिया है, एक पेशी उदूबे साहब हैं, उन्होंने दिया। इसके अलावा हमारे कॉलेज के जो सहयोगी हैं डॉक्टर मोहम्मद साजिद हैं, डॉक्टर अब्दुल कयूम हैं, ये प्रिंसिपल हमारे यहाँ के सुल्तान साहब है, डॉक्टर आकिल हैं, और हमारे नेशनल इंटरनेशनल जो है राइटर हमारे डॉक्टर नसीम सिद्दीकी साहब, इन्होंने हमारा पूरा सहयोग दिया है। और राजेश शुक्ला जी हमारे सामने बैठे हुए हैं, इनसे हम लोग मार्गदर्शन लेते रहते हैं, और आशा करते हैं कि आने वाले साल में फिर हम जो है सुशील जी के सहयोग से और डॉक्टर शुक्ला जी के सहयोग से फिर प्रोग्राम करेंगे, और सभी ने बहुत एंजॉय किया होगा। हमको तो प्रोग्राम बहुत पसंद आया। आप लोग अपनी जरूर प्रतिक्रिया दीजिएगा, जिसके लिए हम आप सबको सुनने के लिए, देखने के लिए, प्रोग्राम में शामिल होने के लिए हम आपके तहे दिल से शुक्रिया करते हैं, अदा करते हैं। थैंक यू।
Dr. Dilshad sir, for nice talk, and last one information for all participants: your certificates has been sent to your registered email. If any major correction found by you, so you can send through the mail, and corrected certificate will send you within a week. And all the data taken from your side and during your registration time you filled that. So I think it's time to bind up our program. So thank you once again, Dr. Manoj Kumar sir. And now Professor R.K. Shukla sir.
Yes. I inform all participants that our organization is also published books and book chapters. If everyone is interested to publish their books as an author or as a book chapter, we are invited to please send us, and we can process through as we concern our expert, and then we publish your books.
Yes, thank you, sir. We have own publication house named by MKSES Publication House. Is a very renowned publication house, and Professor R.K. Shukla sir is the chief editor of that publications. So if any interested participant you want published test book, edited book, research book, so you may contact to Professor R.K. Shukla sir. You may can visit our publication website MKSES Publication. You may search Google MKSES Publications, and you can contact to that address. Okay. So Professor R.K. Shukla, if your permission, so we can bind this program.
Yes.
Thank you, sir. And once again, to good evening to all of you, and our resource person also.
Thank you, sir. Thank you, sir. Thank you. Thank you. Thank you. Lot of thanks.